I know you know that this is Space Week. The reason why I'm here, and I try to make it often here, is because of what happened to SDS-107, the crew, and specifically Ilan Ramon. Okay? It's the anniversary. Actually, today in the morning, the family is at the gravesite. Right now, as we're speaking, I think it's right now, maybe in an hour. And so this is a special week, a special event, and it's important for Israel also. Okay, so that's why I'm here. So let's look at space, and it says a path for our future. So the first thing that you need to know, if you want to know about your future, is to know where you are at right now. And remember, I'm a biologist, so if you want to correct me, it's fine, don't worry. But you are somewhere here, or it might be a little off. I might have moved the arrow. But the key point is, we are in this little spot, this tiny little dirt of a spot there, in this big, gigantic galaxy. And you have many of these, many of these, and we're this little spot. So when you go on the beach in Tel Aviv and you look at that one grain of salt and you say, the sand, and you say it's so small, think about it. Relative to the universe, Earth is smaller than that. That's where we are at. That's our location. So how did we get here? Well, you could look at the evolution of Earth. You could break it into 6 steps if you would like. Matter, space, light, darkness. Earth had this volcanic activity that then created supercontinents, super oceans, basically big land masses, big oceans. Then life started somewhere in the ocean. Yes, we are tiny. Life started in the ocean, created photosynthesis, changed the atmosphere, created oxygen in the atmosphere, allowed life to evolve onto land, and then created small animals, mammals, and then, of course, us. Another way to look at this, I guess I'm standing too close to the speaker. Another way to look at this is this. This is a scientific way of saying what I did. In terms of life, these are the evolution track of what we think, how life evolved on Earth. At the end of this, you see this area right here? See that? That's humans, right? What's important there, and I'll tell you what's really, really important in that part, and that is me. That's what's important in the whole term of that evolution. I am here. And by the way, if you look at my career, I was scared of heights at one point. Yes, a black and white picture tells you something about age. At one point, I thought I was a rabbit. You could try to figure out what holiday that was. Hopefully you could figure it out quickly. I loved this hat because I was very confused. I actually went to the US with this hat. And I went to the US from a place that allowed me to do this artwork for my mom. And so do you see that, what it says up there? Leima. Yes, to my mom. I'm still my mom's kid. I actually talk to her every day. So by that, you could understand that if you say anything bad about me in Hebrew, I'll understand it. And if there's any questions that you have, you don't need her to translate. You can just say it in Hebrew. But the reason why I'm speaking in English is for 2 reasons. One, I left Israel when I was in 4th grade, somewhere. So my Hebrew is about that level, a little higher than that. And second, more importantly, is just like teachers like to do, I like to torture kids. So I might get difficult for you by speaking English. Okay? So, how many people here like science? That's a lot of people. How many people here hate science? How many people are still asleep? Okay, so this is me. Beautiful clothing, beautiful haircut, probably the best look you would want to have in junior high school. This is actually not in junior high school. This is in 4th grade. This is about 5th or 6th grade, this picture. Okay, so this is a blackboard, by the way. Before whiteboards, there were blackboards. Well, there were blackboards and green boards and whiteboards and not computers and other things. So this is chalk that was used here. But what you could see here is that it says Jacob, means I knew how to spell my name. It says 5 plus 5 equals 1. Come on, that's funny. I thought it was funny in 4th grade. It says scientist here, the word scientist. And it has a rocket. Okay, so that's what you see me in 4th grade. Now, later on I had great parents. You could see we weren't that rich because you could see my mom's plants in the back and all of that. But love the hair. Just great hair. Perfect. Model rockets, flying model rockets. Almost burned the house once. Don't ever try to do that. But it is important because all of us have 2 things. We have curiosity. Oh, and this is not me, as you can tell. It's actually cuter, I think, than me. We have curiosity, right? The need, the desire for knowledge, whether it's to figure out how to solve a problem or to figure out how to win a video game that you're playing, an app that you have. Either way, you're curious about figuring it out, and you're willing to explore, right? The act of gathering information about the environment or the surroundings. You're willing to go out there and explore. And as humans, or as people, we have both of those from the beginning. Curiosity, exploration. And what?
Monkey.
And monkeys. Cute monkey. So, space. Space allows you to do many things. Space allows you to look at your past, your present, and your future. Right? Curiosity. Past, present, future. If you take a telescope and you look at something in space, you're actually looking at the past. Because those stars and galaxies are so far away that it takes a long time for the light to get here. So what you're seeing happened a long time ago. And the further out you look, the further in history you're looking at the universe. So you could learn on how we began by looking out in space. It's important. That's why we have large telescopes. That's why we look at them. Why is that important? It is really important to know your past, because without the past, you really have no future. So where you are now is dependent on you knowing your history, your culture, everything around you. That's why it's important to study history. Not that I was the greatest student in history, but it is important to do that. So NASA Ames, a few years ago, launched a satellite. It was actually a secondary satellite. What that means is that there was a big satellite and a small satellite, and we launched the small satellite. And what we wanted to know is there water on the moon? So the first question is, well, you could read the answer, yes, there is water on the moon. And the way we did it is we took this vehicle and we had the moon hit the vehicle, because it's not politically correct to say that we hit the moon. So the moon hit us. Either way, we crashed into the moon. And we looked at what came up, and we saw that there's water. Now, why is water important? Go ahead.
Because life can be evolved.
Here, why don't you? I don't think we could pull that out. You can get up.
Okay.
Good.
Life can be evolved in water.
Life could evolve in water. Yes, that's a good answer.
Without water, there's no life.
Without water, there's no life. What did you want to... What? So water is important for life. You see, so everybody hits all the right answers because I'm a biologist. You better get this correct. Most of what you are is water. So water is important. It's water for the evolution of life. It's important for the continuation of life. Imagine if you had no water. You wouldn't have Coke. You wouldn't have all the rest of the drinks also at the same time without water. You wouldn't have anything. So water is important. And the moon that looks like a desert has water on it, has a lot of water on it. So this is Mars. So there's Earth, there's Mars, and there's Venus, right? There's two planets across each one of us. Mars has water on it.
Yes.
Has lots of water on it. But not only does it have water on it, it's in a liquid form in certain areas, right? It cycles. The other thing, and we have this Mars Curiosity rover right now on Mars. If you haven't seen 7 Minutes of Terror on YouTube, go look at it because you'll understand what it took to get it there. The point being is, we're trying to figure out, was there life on Mars? Is there life on Mars? And can we inhabit Mars? Why? Because besides water, you need carbon sources and minerals. Mars has all of those, right? So you could have life there. This is an amazing vehicle. What else is important for life? The other thing that's important for life is energy. It's the sun, right? You need that heat source. So another mission that the center that I'm involved is currently involved, this is a current mission, is called IRIS. And what IRIS does is it looks at the sun. Oh yeah, by the way, as chief scientist, you get all this data to show on slides. It's really great. This is actually data from IRIS. And what it's studying is how the sun works. What's the mechanism behind it? It is important for us to understand how the sun works. Why is it important for us? Because we want to survive, we want to live. But also it's important for us to understand about life. So we have this satellite currently in space looking at the sun. And specifically looking at the details, very much on the details of what you're seeing there. There are things that are called solar flares. Solar flares are these energy sources that come out of the sun, and they actually affect us here on Earth. Now let's look at this. You know, a few years ago, let's say if you look 200, 300 years ago, most people believed that planets are the planets that we see around here, and that we either were created naturally or by God, but either way, the planet Earth and planets are unique. We have another mission called Kepler. Yeah, but Kepler, the mission is really interesting. What Kepler is doing? It's looking at one area. Remember I showed you all those planets and stars that you see there? Now it's looking at that space. And it's trying to figure out how many planets are out there, orbiting a sun or two suns or so on. And what you could see is, wherever we look, we see planets. There are planets everywhere. This is the number of planets that are predicted. This is the number of planets that are confirmed. Now this project took the researcher 30 years to do. Why did it take him 30 years? Because he envisioned doing this experiment, but the technology didn't exist. So he knew the method. Now he has the technology to do this. And what is the technology? This is the technology. When a body moves across an object that has light, you will see it dim. That's all the technology that is there. But you're looking at tiny little dots. So think about it. When you walk in front of a light, if somebody is looking at it, you'll see a decrease in light. So if something is orbiting a sun, you should be able to see that dimming on light occur in a predicted pattern. You should also be able to determine its size and how much dimming you're doing. Okay, simple math, simple physics, relatively, gives you that type of answer. So we talked about Mars, and somebody mentioned that there might be liquid water on Mars. That question is important. It's something called a habitable zone. So if you're looking at planets, you want to know, could they hold life? If life in another planet is similar to our life, it will need water, carbon source, organic material, minerals, and they would need to be in liquid form. So there's something called a habitable zone. Depending on the size and age of your sun, the zone is different. And so when you're predicting the orbit of the planet, you try to figure out which ones fall within the habitable zone. And guess what? There are planets in the habitable zone. Now, does that mean there's life on it? No. But there are planets that are in that zone. So that's important. And why is that important? Anyone want to guess why is that important? Why are we spending all that money and lives on that? Go ahead.
Because if we discover a planet that is in the habitable zone, it has a carbon and sun and water, the chance we find aliens too.
Yeah, but some people will say we have aliens already on Earth. But yes, correct. You might find life on there. Why else study other planets? Sometimes what? Oh, sometimes Earth will die. Yeah, that could happen, actually.
When is the next ice age?
When is the next ice age? That's correct. Go ahead.
Just like Wall-E, we could run out of place on Earth and populate it with garbage, and we need a new place to live on.
So it's similar, the destruction of the planet, whether it's by us or some other source. Anybody in the back? No opinions. Come on, I'm in Israel. You know, I always blame my multiple opinions on the same subject because I'm from Israel and from New York. But okay, so the reason why that is important for all the stuff that you heard here, the potential for life, for understanding where we came from, how we evolved, but also to understand our future, where we could go. So besides Mickey Mouse, I also like Star Wars and Star Trek, and I want to drive that fiction to reality. So rather than like most kids now who sit there and just play the video games that are the reality of somebody sitting in the Bay Area, where NASA Ames is, by the way, Google all those people, I rather take that fiction and make it reality. Right? So make what I see in Star Wars or Star Trek and try to bring it back to the real stage. So I'm not the only one that thinks that way. We always have the need to explore, and we have the curiosity of what's out there. So I show this picture, and I showed it in the Ilan Ramon conference, and the reason why I showed it is because Ilan Ramon actually took a copy of that to space. And what this picture is a kid in a concentration camp drawing what it would be like looking at the Earth from the moon. Now, personally, if I was in a concentration camp, I wouldn't care about the Earth. I would be looking outwards. It's really interesting to see that. We have science fiction, space station, space shuttle. This was written by a German that went to the US. The father of our rocketry, von Braun. And the point being is we built a station and we had the shuttle. the Russians flew a dog. Then we got moon, a man in space, and then we got to the moon. There's always that need, right, to want to go and explore those places. I personally want to go to some of those places. Let's pick some. These are 3 choices. You could pick other choices, but these 3 choices are doable relative now. One of them is the moon. Another is Mars. And this is just a rock. It's an asteroid. Note, not to scale. I'm a scientist, so I have to point out that the rock isn't the same size as the moon or Mars. They're different sizes. But there are places that we could go. And not only could we go there, we could live off of there. Why? There's water and minerals here. There's water and minerals here. And depending on which rock you pick, there's minerals, water, and even things called amino acids. Amino acids are what makes up a protein, and a protein is part of what makes you who you are. So 2 questions. How do we get there from here? And how do we survive the elements? What I mean by the elements, radiation, gravity, temperature changes. How do we survive those? First, you need to have rockets. So these are a lot of different pictures of rockets. I don't have every country that has rockets. I think I'm missing a country that's close to here called Iran on here. But I do have China on here. I have the US, I have Russia, I have India. And this you might not recognize, but this is the models of the Israeli Shavit, right, which flies. You have a rocket. You know, Israel does launch satellites into space from here. They don't have to go somewhere else. Yeah, and the satellites themselves, it's really tricky because most rockets fly with the orbit of the Earth because that's assisting, using that to get out of the gravity of Earth. In Israel, you fly against it. You know why you fly against it?
Because the surrounding doesn't allow you.
Yes, the surrounding doesn't allow you. So imagine having a missile fly over, I don't know, Syria or Lebanon right now. They'll think you're attacking them. Or they'll attack it. So Israel has to use more energy to get up there, but it's done. The other thing you need to do, in science, you need to repeat things. So if I'm going to conclude that gravity affects, I don't know, the way I think, maybe I'll think better when I'm outside in space. But if I'm going to do that, I need to have an experiment that shows that. So the ability to repeat it, not go out to space once, but do it often, is important. In this case, you're seeing the International Space Station, which currently orbits Earth. And it is international, right? You could live there, you could do experiments. Astronauts stay there 6 months or longer. But there are also these little things. There are small satellites that space agencies use, companies use, colleges use, high school uses, middle school, junior high school, elementary school. Lots of people are building them, even kindergarten. What we did at Ames, and I'll show you in the next slide, is we used the concept of not reinventing but adapting to create a satellite that runs off of a phone. I think I had the phone somewhere, wherever I put it. Wow, very good. You know, if I would lose this, I would get in trouble. You know why I would get in trouble? Because the other part of my job is I get fancy equipment paid for by the government, and this is government equipment. So we actually ran a satellite off of this phone. Well, it's actually an Android phone that we used. And the beauty of it is that this is cheap. It has a GPS system in it. It has a communication system in it. It even has a camera, so somebody who mentioned cameras back there. We took pictures with a camera from off of a phone in space. Okay, that's phone sats. They're up to version 2.5 now of that. Another thing that is a concept is how many people played Legos when they were kids? Legos? I played Legos. I also played, there was this construction stuff. Perfect. So realize this. Legos are universal pieces, right? You could take one piece and connect it to another. Well, you could apply the same thing to building satellites. See, this is Lego for satellites. You could take different pieces and make something that goes around the planet or something that lands on a planet, right? Just by mixing and matching the different pieces. Why is that important? Well, it's important because it makes things cheaper to do. And if it's cheaper to do, there's more of a chance that you'll get there, to Mars, to Moon, to that rock. So the first one is called LADEE. LADEE studies the atmosphere and the dust environment of the moon. It is orbiting the moon right now. And now I'm going to stop for a second. It's going to go to space.
3, 2, 1, drop.
This is away.
This is called an air launch.
And ignition of the Pegasus rocket.
Attitude remains nominal. Power buses remain strong with good voltage on all buses.
This is why I work for NASA, by the way. I get to see this stuff and get
This
paid for
Pegasus
it.
is underway.
Properly, fins are following commands and controlling the flight of the vehicle.
Okay, so that's Pegasus. It's actually a rocket that was used for military that was converted to fly satellites.
T-minus 15 seconds.
Green board.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, engine start, 1, 0, and liftoff of the Delta II rocket with Kepler on a search for planets in some way like our own.
Vernier engine chamber pressures are building. Grounded solid motors are building chamber pressure.
It's from the base. It's on the ground.
Increasing at this time. Pressure's looking good. Burning out of the solids and for separation.
So solids is solid rocket motors. There you go.
You see separation, and we have ignition of the air-lit solid motors.
Okay.
Air-lit solid motors building in chamber pressure.
So everybody is awake? Good morning. I see a hand up already. Go ahead. Was I involved? No, I wasn't involved. I was involved in the area of overseeing the science that occurs within the center. All these missions are at NASA Ames, but I'm not the scientist on those missions, and I'm definitely not the engineer who gets to design these things, right? Although I did work with teams that built satellites. There are satellites that we're doing with Israel that we're working on. The point is, it takes lots of people to put this thing together. Lots of people across lots of places, and even many countries to get them together. When you see the launch, you might have had one little step in it, but because you worked as a team, you get a success. And so, yeah, for me it's exciting. I get to see it. I get to help in the process to get it done, but I'm not the scientist who's operating that. Any other questions? So now, how many people want to be astronauts and want to sit on the top of that? Yeah, I still want to do it. With all of that rocket fuel and stuff. All right, so let's continue on. So remember, I'm a biologist, and I'm in an engineering organization, actually. But what's interesting, you know the word evolution? What's the word evolution in Hebrew? I always love when people say that. Yes, it's such a difficult word. So evolution. You know, the debate of whether evolution occurs or not In the US, it's a big debate. There are lots of people that don't believe in evolution. If you remember what I said at the beginning of how I said the world began, I pointed out that I said you could break it to 6 steps. Well, you could relate why I use the word 6 steps, but evolution does occur. This is the evolution of a wheel that's on a car, right? A tire that goes forward. You had stone, you have wood. It continuously evolved based on being selected for what's better for its purpose. But one thing that was kept consistent throughout all of them was the standard of a circle. That's important. That's why you want your iPhone Model X to be compatible with the next one. You want to keep certain consistency across there. When you do that, you speed up the rate that you could go. So if you want to go to Mars within your lifetime, what you want is not to always start from the bottom of building a rocket first. You want to use that knowledge and push yourself forward to the next step. So how do we survive the elements? So we talked about gravity. The other things that are really bad in space is radiation. We have an atmosphere that protects us from the radiation. If we were out there for an extended time, we could die. Well, actually, we will die. The reason why the astronauts who are in the International Space Station don't have such a major issue, it's because they're still in the zone of the Earth gravity and the atmosphere that protects them. They're not outside the gravitational field of Earth, and that gives them some protection from the radiation. But if there's a solar storm coming from the sun, they still get hit with a high level of radiation. The other things that occur. Well, let's look. Where there are issues, there's a potential for advances. So in life, when you go through and you want to be, let's say, yesterday I was at an Israeli Air Force base. Really cool. Got to see planes fly. Now, if you want to be a pilot, it's really great, but the chances that you'll be a pilot are small, right? When you hit that wall, when you hit something that you can't achieve, don't look at it as a negative. Look at it as a positive. See what you could learn from that experience. So when you go to space and you have radiation issues, you have no gravity, you have all these things, you could look at it as a negative, or you could look at it as a positive. Remember, it's a disruptive event, but it leads to new opportunities. So space, here's biology. So when you have a plant outside like a tree, it grows against gravity and toward light, right? The roots are growing toward gravity, against the light, toward the water, right? That's what a plant does. If you go to space, and this is a moss, which is similar to a plant, it no longer has a gravitational field. What happens is you get this fuzzy ball that gets created in space, right? There's no gravitational field. But realize this, if you did it only once, that doesn't mean that it's because of space environment. It could be just because something went wrong. So you have to repeat it. This is the repeat. Okay, the first time on STS-87, the second time on STS-107. Do you remember what STS-107 is? It's the space shuttle that Ilan Ramon was on. That space shuttle was all for science experiments. It wasn't there to build the space station. It was to do science. This is a result that survived. This came from that flight. There are more of this type of data that I could show. But the point is, it repeats this experiment that says when you take mass up to space and you take away gravity, the direction is lost. It also tells you, by the way, that there's a direction to the rotation here. So there's a lot more to it that you learn from that experiment. Let's look at a different experiment. If you take a bacteria or a yeast and you take it up to space, what you see here when you return it And don't get scared because this is just temporary, transient. It reverses itself. But if you grow these microbes under specific conditions in space, they kill more mice on return to Earth than if you didn't. And what's important about that? Well, you could try to figure out what the difference is, and this shows you that they solved it. They changed the media to grow it, and they get a different result. And what's important about that is because you could use that knowledge to cure people on Earth here, right? It's a disruptive environment. It lets you have new opportunities to look forward to. And again, it's repeated twice. So for those who want to be astronauts, so examples from space biology and astronauts themselves. Okay, so how many people have grandparents here? This is for everyone, lots of grandparents. How many people have a grandmother or a grandfather that have weak bones? Weak bones, bones that are brittle or that are not very strong. My mom has it, okay? How many people have seen people in the hospital that are there for long term? I've seen them, they get muscle loss. If you want to cure bone loss and muscle loss, you could study it on people and animals that experience it on Earth, or you could study it in space, where it occurs naturally. You could figure out how to solve those questions by using space as your model. Amgen, which is a company that has some drugs for bone loss and muscle loss, actually works with us to do some tests on that. How many people still want to be astronauts? So, there are one other thing that I will say, and I don't know how to say it exactly, and I don't want to know how to say it exactly in Hebrew. But your reproductive system, that is the system that allows you to have kids, changes in space. How many people still want to be astronauts? Okay. But if we're going to go there, if we're going to go to space, you're going to have to know one thing. Currently, if you go to space and you go for 1 year, you need to take 11.3 metric tons of material out to space. So you have to load all that stuff, put it on a nice big rocket, launch it to space for every year that a person is out there. And the interesting thing about that is that I actually talked to friends in the Navy, and that is the number that they calculate for ships. Okay, so it's the same number. Now, if we were to go to Mars or to places where no man has been before, like to where Kepler is, and we're going to keep man alive, if we're going to do it by taking things from Earth here, we're going to need to take 11.3 metric tons per person. And that's just impossible. You know why that is impossible? Not only because you don't have the money for it.
We don't have it.
But no, we do have it. We could have it. The real big issue is, you saw how much smoke comes out of those rockets? Think of how many rockets you would have to launch and what it would do to the environment that you live in to get all that supply up there. So what is the solution? And now I'll give you a hint why a biologist works at NASA. The solution is biology. Why is the solution biology? Well, when the cavemen left the cave and went to a new place, they didn't take the cave with them. They didn't take everything with them. They might have taken an animal that looked like a chicken or something, and they took seeds with them. And they grew the food where they went. They made the food at the place that they went to survive. So biology allows you to lower your mass, to lower the weight of what you need to take. It self-replicates, fast-growing. You could change it for the environment that you're going to be. Less gravity, more radiation. It's flexible. And this is an important word. You could manufacture it. Okay, you could produce it. So biology is a tool that is important for space exploration. But you're going to say, but, you have to. This is Israel. You have to say the but. At least I say it. But you just told us all these things that occur in space for life, that destroy life in space. So how could you do what you're saying here. How would the plant grow normally in space? Well, now this is what we're looking to do. And that is the area of synthetic biology. Synthetic biology states that if I understand biology good enough, right, I could then use it sort of as an engineering tool. I could get a tree with, by the way, most of the stuff that you sit on, even your cotton clothing, and then you go into plastics, which is a manufacturing of biology. You're moving from rocks to tin to organic material. The reality is, once we understand it, we could control it, we could build with it, but we could even do more than that. So, you know, I think it's Star Wars, I don't know, 1, 2, they changed the numbers. See, when I was a kid, there was only 3, and then they did another 3, right, later on. But if you look at later Star Wars, you could see a spaceship that goes up, and it changes its shape and flies off. It's hard to do with metal. But there's lots of organisms that on Earth change their shape for their environment. So imagine having a rocket ship that goes up, that's built partially with metal, partially with biology, gets hit by rocks in space and is able to repair itself. And not only that, it's able to change itself to the environment that it's going to be before you get there. Is it the future? It's at least the future that I'm selling. Is it your future? Well, if I'm successful, and if the friends that work with me are successful, yes, it will be your future, right? The point being is, that is how we're going to do space exploration. And why we could do it? Because there's water on the moon. There's organic material on the moon. There's water on Mars. There's water on rocks. It's everywhere. And that's why we could take biology everywhere to do it. So the other part of being at NASA, of course, is the beautiful pictures. Isn't this beautiful? I think it's beautiful. So I do want to thank you, but before I do, and before I let you ask me questions, I'm going to say this. The key to long-term success is imagination, persistence. Okay, so those two almost everybody knows, right? Imagination, you have to have a dream of what you want to happen, what job you want, where you want to work. And then you got to work hard at it to get it. You won't necessarily get it the first time. And by the way, if you do get it the first time, it won't be so fun because then it's too simple. It's not a challenge. But the thing that most people forget is compassion. You're not successful in life if you're not compassionate. And what does compassion mean? Compassion means thinking about the fellow person next to you, the animals that are around you. And it's not your friends, because that's simple. Compassion is about the person that's different than you. Rather than laughing at them or making it difficult, do the hard thing. Accept them. Rather than look at an animal and say, who cares? Do the right thing. Think of it. It's an animal that needs to survive. If you're compassionate, then you're truly successful in what you're doing. And one other thing that I'll leave you with is think about this. How many people want to have a Ferrari? Well, maybe a Maserati. Or maybe a Porsche. I'm still debating, by the way. Yeah, well, a Tesla also is good. How many people want to own a house right on the beachfront in Tel Aviv or in Hawaii? So you know what you need for that? Money. So let me tell you something. This is something my dad told me once. What is truly yours in life? Because remember, life is very short. And we are that little speck of dust. You remember that dust that is nowhere in the universe. So what's really yours? That is personally yours? I'll tell you. Your money will stay in the bank. Your house will stay to whoever has stayed there when you're gone. Your family will stay behind when you're gone. What goes with you is what you studied, what you learned about the world. That will disappear from this earth when you leave. So that is truly yours. So rather than going after the Ferrari, the Maserati, the Porsches, the beach on Tel Aviv or in Hawaii, think about it. That's just temporary. What's really is yours is what you learn about this world and the next world and the universe. And yes, and support space research. So with that, I'll thank you. And you can ask questions.